Hi, I'm Andrea from the Human Touch Robotics, and today I'm going to speak about the limits of current robots. In recent years, we probably saw a lot of cool robot demos. You saw robots walking, jumping, doing backflips, doing all sorts of different movements, doing some karate moves. You saw robots trying to help in your kitchen, trying to do dishwashers, trying to load your washing machine, and so on. We would say that robots have demonstrated some impressive capabilities or impressive locomotion capabilities and maneuverability. Some have also demonstrated the capability of robots to generalize across several tasks. And many are using buzzword physical AI, promising us that robots will automate everything. For example, we are using robots to record this video. But I pose a question, what we didn't solve? What robots didn't demonstrate? What are the limits of current robots? Well, robots cannot still grip objects like humans do. We say that robots don't possess adaptability of the human hand. It seems that for robots, the human hand level dexterity is still out of reach. When you think about it, when we grip items, for us it comes quite natural. It becomes quite natural to pick a tomato, then lemon, and so on. When we do it, we don't even think about that. But for robots, it is really hard to achieve. So why it is hard to achieve this for robots? Well, when robots are picking objects, as you can see here, each object is unique. The tomato is different from onion, different from lemon, and so on. Every object is different. Some are large, some are small. Some are rigid, others are soft. Some deform instantly under pressure, while others resist. As I mentioned, for humans this variety feels natural. We instinctively adjust how we grip a tomato versus a lemon or an onion versus an avocado. We don't calculate forces, we feel them. For robots this is incredibly hard. Traditional robots need to know in advance exactly how much force to apply. If too little force is applied, the object could slip. Too much force is applied and the object can be damaged. Picking fresh food items is especially difficult. Every tomato is slightly different. Each onion has its own shape, stiffness and surface. No two items are truly identical. This level of variability in items is one of the hardest problems in robotics, and adaptive gripping is often called the holy grail of manipulation. At DHG Robotics we spend years solving this exact problem, and especially gripping fresh food items. That is why we built Dexter, this black finger gripper you see here handling every item throughout this video. Dexter is an adaptive robotic gripper designed to handle extreme variability. It doesn't rely on object models, pre-training or data collection. It doesn't need to know what the object is beforehand. Instead, Dexter adjusts in real time. Think of it like a human hand that constantly senses and adapts, tightening, relaxing, and stabilizing its grip while the object is being picked. What you are seeing here is a dynamic adaptability. Dexter has never seen these items before, yet it grips them safely, securely, and gently on the fly. A soft tomato, a firm onion, a smooth lemon, bananas, cucumbers, avocados. Each one requires a completely different grip, and Dexter automatically adjusts its force at high speed without crushing them or slipping the items. No pre-training, no fine-tuning, no object-specific data. Just adaptive manipulation in real time. This is why Dexter can handle a wide range of fresh food items. and we demonstrated some like tomatoes, onions, lemons, avocados, banana, cucumbers, but it can do many more. And these are really fresh food products. Dexter is our answer to adaptive object manipulation. And when combined with robotic arms, it enables something that has long been out of reach for robotics. Reliable, scalable automation of fresh food handling and many other items. But all of these things is really nice. We demonstrate the ability to pick soft items and fresh food items. But as you see, a lot of items have a lot of free space around them. And someone can claim, well, in reality, most of the bins are full of those items, and items are really close to each other. So, then, what then? Can we handle picking of items from a bin when items are really crunched and close to each other, like you can see here? So that poses another challenge, how we can now handle this. How prepare and how robots can enter into this clutter space and safely pick an item, but also so that it doesn't damage that item and also all surrounding items. But now. Well, this is something for another video clip. Right. What about packing? We don't think about how we can approach items and how we can handle them.